Increasingly, our lives, lifestyles, culture, and economy depend on wireless devices. Wireless devices enable us to remotely monitor our sleeping children, turn on the television without leaving the couch, make phone calls whenever and wherever we want to, pass through toll booths without stopping, and use our laptops and personal digital assistants virtually anywhere. These devices and many others in our modern world work because of a powerful resource called electromagnetic spectrum. Things like clean water and abundant electricity have become so ingrained in our lives that we take them for granted. The process of water treatment and the production of electricity have become highly technical and complex. Thankfully, we can be consumers of these commodities without becoming an electrical engineer or water treatment chemist. Recently, electromagnetic spectrum has reached the same impact on our lives as water and electricity. What these resources do for our lives is much more important than knowing how they work. Electromagnetic spectrum, usually referred to as spectrum, encompasses radio waves, infrared, visible light, ultraviolet light, X-rays, gamma rays, and cosmic rays. Radio waves are an incredibly versatile area of the spectrum. Radio waves make much of our modern communication possible, including television, AM, FM, and satellite radio broadcasting. While spectrum makes our lives more enjoyable, it is, in fact, critical to our modern quality of life. For example, modern healthcare depends on spectrum to operate medical monitoring systems before, during, and after the patient is hospitalized. Public utilities use spectrum to remotely control pipeline valves, which direct the flow of our water, electricity, gas, and other utilities. Transportation relies on spectrum for cargo tracking, air traffic control, and security sensors. Firefighters, police, and emergency service personnel use spectrum for rapid communication, location positioning, and other services. And spectrum allows manufacturers, shippers, and merchants to monitor the location of products using advanced identification technologies. Our naval forces are especially reliant on spectrum. The Navy and the Marine Corps track shipments of critical supplies using RFID. Medical staff use unique RFID-tagged bracelets to confirm patient identity and enter diagnosis and treatment. In addition to implementing commercial technologies, our naval forces have unique spectrum requirements. Communications, radar, air and fleet defense, weapons guidance, command and control, and many other systems rely on spectrum. In fact, network-centric warfare is impossible without spectrum. Marine Expeditionary Forces, with integrated aircraft and combat service support, along with Navy SEAL teams, submarines, and battle groups, are often the first to arrive in theater and must rely on spectrum to remain highly maneuverable, flexible, and tactically effective. Modern naval battle groups must have spectrum to operate. A good example of complex spectrum demand is found in a typical naval aircraft. Voice communications and digital data links require many wireless devices. Weapon systems with associated fire control radar rely on spectrum for guidance to find and destroy their targets. Such demands have both expanded our military's need for and increased their dependency on spectrum. A critical challenge is that spectrum is a finite resource, and it is in great demand. Without careful planning and implementation, spectrum-dependent systems may interfere with each other unintentionally, but adversely. For example, a test flight at a naval air station was delayed because of interference to an important ground-based test measurement instrument. The source was a malfunctioning baby monitor in nearby military housing. Providing balance between spectrum-dependent devices that make our lives more convenient and those that are critical to our national defense is a growing challenge. Obviously, new technologies to improve wireless efficiency will be needed to maintain a balance between national defense and economic strength. In the Department of the Navy, we are constantly exploring technologies that allow us to utilize spectrum in innovative ways. For example, frequency-agile technologies can sense a competing device on the same frequency and instantly switch to available spectrum. Using software-defined radio, the frequency ranges, power, modulation, and nearly every other characteristic of the device can be set or altered by simply loading new software. Ultra-wideband devices can even see through walls to detect combat threats without entering a building. In addition to implementing new technology, we must all collaborate in the efficient use of current assets to guarantee dependable spectrum access for everyone. The complexity of spectrum coordination is enormous. Imagine the global challenge. The Department of the Navy deploys Marine Corps forces and Navy assets worldwide. Careful and constant coordination is required to guarantee that the department meets its mission. Through international negotiations, the Department of the Navy ensures that the spectrum-dependent capabilities of the Navy and Marine Corps are preserved. Because the radio frequency spectrum must be shared among nations, a specialized United Nations agency, the International Telecommunication Union, or ITU, convenes the World Radio Communication Conference to modify spectrum allocation as technology and services require. Preparations are intensive. All members of the United Nations are invited to these conferences. The Department of the Navy Chief Information Officer participates as the department's national and international representative to these forums. To achieve its goals, the Department of the Navy is also working to improve efficient use of spectrum through collaborative efforts among business, industry, government, and other nations. In the end, spectrum access is the key enabler for information dominance. To maintain America's advantage and secure our country's future, we must work together to meet our growing national spectrum challenges, because electromagnetic spectrum is critical to both our nation's security and economy.